Now, we will see few techniques, right, or technologies that are used to fabricate this integrated circuit. The first one is monolithic integrated circuits. What is monolithic integrated circuits? Yeah, very interesting. You see, we divide this monolithic into two parts, all right. One is mono, means single, one, all right, and lithic. Lithic comes from the lithos. So, how we got this word? The word comes from Greek, all right. Monolithic comes from the Greek words, one is monos and second is lithos, that means single and stone. That means that if you carve a single stone to a sculpture, it is monolithic, all right. So, what do you think, why it is monolithic integrated circuit? That means that we are using a single structure, right, or single crystal to fabricate our integrated circuit, right. So, we have to use this silicon and we have to do lithography to form your integrated circuit. That is why mono and lithos, right, monos lithos, monolitho, monolithography or monolithic integrated circuit, all right. So, the monolithic ICs refer to a single stone or a single crystal. Now, again confusing word crystal. What does crystal mean? No, crystal is nothing, right? Crystal means just a silicon. You see here silicon, silicon. Don't worry. It's very easy. Okay, so or a single crystal or single silicon, single crystal silicon. The single crystal here refers to a single silicon chip as the semiconductor material. The point I am making here is that the single crystal in this monolithic integrated circuit is nothing but a silicon chip as a semiconductor material, and on top of this semiconductor material we are using all the passive and active components which are interconnected, right. Here see what we have read, the single crystal refers to a single silicon chip as the semiconductor material on which passive and active components are interconnected. Nice. Now, what is the advantage, right, or why monolithic ICs are considered as the best mode of manufacturing IC, as the best mode, all right. So, why they are considered best? What is there that they are considered best? So, let us see what is that they make it best. First is it can be made identical, that is really good, right. It is highly reliable, it can manufacture in bulk in very less time, and when it is manufactured in bulk in very less time, it will result in low cost. So, because of this parameter, it is considered, or monolithic ICs are considered as best mode for or mode of manufacturing, right. Let us see once again, it can be made identical, high reliability, it is manufactured in bulk in very less time, and finally it is low cost. So, this parameter together will together helps to make monolithic ICs to be the best mode of manufacturing. And what are the limitations for monolithic integrated circuits? One, low power rating, that means it cannot be used for high power applications, and it can have power, or it can't have power rating of more than 1 watt, it cannot be used for high power applications. What is the next limitation? Isolation between components within the integrated circuit is poor. What is next one? Components such as inductor cannot be fabricated. What is next one? Passive components with the ICs will have a small value and external connection is required. What is next one? Flexible circuit is not possible. So, there are certain limitations associated with monolithic integrated circuits. What are thin and thick film integrated circuits? These integrated circuits are larger than monolithic integrated circuits. First point that you have to remember is these integrated circuits are larger than monolithic integrated circuits, but at the same time they are smaller than the discrete circuits, alright. So, thin and thick film integrated circuits larger than monolithic ICs, smaller than discrete circuits. Second point, it can be used in higher power applications. So, high power applications can be used. You see the limitations of monolithic ICs were they cannot be used for high power applications, while these circuits can be used. Cannot be integrated with diodes and transistors, right. Now, these are the limitations, right. So, first two are the advantages, other things are the limitations. Cannot be integrated with diodes and transistors, diode and transistor if required can be externally connected onto its corresponding pins. Finally, resistance and capacitors can be integrated. So, let us see what is thin film, what is thick film, and I will give you an example of both thin film and thick film integrated circuits. First, let us see the left side of the screen, and that is written the we have written thin film integrated circuit, right. So, fabricated by depositing thin films of conducting or semiconducting materials on the surface of glass or ceramic base. The thin film, why it is called thin film? Because the thickness of the film is extremely small. So, here we have taken one example. What is an example? R equals to rho L by A. What is this? Very easy, right. What is R? Resistance. What is rho? Resistivity. What is L? Length. What is A? Area. Now, we all know this equation, is not it? So, can we make a resistor using thin film technology, and if yes, how? Can we change the resistivity? It is very easy, we change the material, right. But if you want to change the resistance, right, assuming that the material is same, then what you can do? You can either increase the length or you can decrease the area, is not it, because your equation is R equals to rho L by A. So, what does that mean? By controlling the thickness and width comes when there is an area. So, by controlling the thickness and width of the film, we can fabricate resistors of different values. Different material will have different resistivity. Similarly, capacitors. What does capacitor means? A simple definition of a capacitor is two plates separated by a dielectric or air, right. Dielectric is nothing but insulator. Okay. So, if I want to fabricate a capacitor, I can fabricate a capacitor by depositing an insulating film between two metal films, or in another way it is same thing. What is written? Capacitor can be fabricated by depositing two conductive film separated by an insulating layer or insulating layer between two conducting films, same thing, right. So, this is how we can fabricate a capacitor. We can also fabricate an inductor using thin film integrated circuit. So, these are some of the this is how the thin film integrated circuit can be fabricated. Now, let us see the thick film technology. So, we move to this next section, which is our thick film integrated circuit. So, commonly this is also known as printed film circuits or screen printing or silk screen printing, right. It is obtained to it is used to obtain desired patterns, right, on the substrate, right. Many times I have used this word substrate. What is it? It is silicon, it is glass, it is ceramic, it is plastic, it is the material on which you fabricate devices, right, that is your substrate. You can make quick sensors. If you have seen gas sensors, they are used using screen printing, because it is very easy to fabricate, you see. So, screen printing thick film technology uses the screen printing. Now, let us go to the advantage of thick film and thin film ICs, right, over the compared to monolithic ICs. First is it has better tolerance. You can control the thickness, right. Better isolation between components, flexibility in circuit design, right. However, thin film or thick film can be used to fabricate active components and it will further result in increased size. It is not that it cannot be used, but it will result in increase in size. The next slide is hybrid or multi-chip integrated circuits. So, the integrated circuit is fabricated by interconnecting a number of individual chips. The interconnection of number of individual chip is the advantage of multi-chip integrated chips or circuits. This is used for high power audio amplifier applications. It is used for high power audio amplifier applications, right. Third advantage is you can diffuse the transistor or diodes as the active components. Now, diffuse transistors or diodes can be made on this integrated circuit. Diffuse resistor capacitor on single chip or thin film components can be of some of the passive components that can be fabricated, right. And finally, the metallized pattern or wiring is used for interconnection between the individual chip. That means that there are several advantages when you talk about hybrid multi-chip integrated circuits. So, let us quickly recall what we learned today. First, we learn what is integrated circuit, why integrated circuit is important, right. How integrated circuits are divided into two main group. One is linear integrated circuits, second is digital integrated circuits. Linear integrated circuits example is operational amplifier. Digital integrated circuit example is computers or logic circuits. Linear integrated circuits works on linearity between input and output. Digital works on 1 and 0. Then we saw monolithic integrated circuit, right. Then we saw, so what is monolithic again? Carving from a single stone, right, making or fabricating a device on a single silicon crystal, all right. Then we saw the advantages and disadvantages of monolithic integrated circuit technology. Then we saw thin film technology and thick film technology, and we understood that thin films can be used to the different materials can be used to deposit thin film on the different substrate. It can be glass, it can be ceramic, it can be plastic, it can be silicon, it can be oxidized silicon, it can be insulator on silicon. Then we saw thick film technology. We saw printing shop may have huge amount of experience than you will get sitting in a laboratory and doing a thick film technology, right. So, always remember, discussion, talking with people, understanding, sharing of ideas will improve your knowledge, all right. So, thick film, whenever you go to market, if you come across a screen printing shop, stop by, discuss. Finally, we saw hybrid or multi-chip integrated circuit technology, and then we saw advantages and disadvantages of all the technologies. So, it is always good to read other things apart from engineering, right. Try to read something, right, try to watch. In fact, I will tell you cool examples. You see science fiction movies, there is a lot of fiction, right, but there is a lot of science. So, get the science part and enjoy the movie, right. See what they are showing, whether they are showing a thermal sensors, right, where you can see a person in night, how this thermal sensor would work. So, learn something from everything, right. When you see around, you have lot of things to learn, all right guys. So, I will see you in the next class. Till then, you take care of yourself. Bye.